So hello friends, in this video we shall talk about three-phase unbalanced load. Okay, often in electrical engineering we will be hearing about these two terms. One is balanced load and another one is the unbalanced load. So in this video we shall know what is the exact meaning of this balanced load as well as unbalanced load and why the unbalanced load picture enters here. Okay, so let me first define the three-phase balanced load. Three-phase balance load. Okay, so your three-phase load is balanced when in each phase you will find the same impedance and power factor. Okay, so a three-phase load is said to be a balanced load if the impedance and the power factor in each phase will be the same. Okay, now again, if I say the three-phase load is unbalanced, and it will be unbalanced when in each phase you will find different impedance and different power factors, or you can say different impedances or different power factors. Okay, so the advantage of the three-phase balanced load is when you have some problem and if you solve that problem in a single phase, that by considering a single phase, it is easy because the other two phases will also maintain the same conditions. So by considering a single phase in problem solving in balanced load, you can able to solve it easily for the other two phases as well, because the conditions in other two phases are also equal. Conditions will be equal in the balanced load. But whereas in the unbalanced load, you have to consider the three phases separately, as the current and your power varies as the impedance and the power factor varies. Okay, so that the problem becomes complex in your three-phase unbalanced load system. And basically, if we classify the unbalanced load, we will be having four-wire star connected unbalanced load, delta connected unbalanced load. Okay, delta connected unbalanced load. The third one is three-wire star connected unbalanced load. Okay, but in this video we shall focus on only this load, that is four-wire star connected unbalanced load, because for most of the commercial and industrial purposes we will be talking about the three-phase four-wire supply system. That is three-phase four-wire supply system. And for this three-phase four-wire supply system, you can connect your three-phase loads. Okay, you can connect your three-phase loads. Okay, or you can connect three single-phase loads individually. Three single-phase loads individually. Okay, so for the three-phase four-wire supply system, you can have or you can represent the load in two forms. One is in the representation of three-phase loads, that is three-phase load connected to a three-phase four-wire supply system, or you can have three single-phase loads. Okay, so here I have shown the representation. Let me say this is R, Y, let me say this is neutral. Okay, this is coming from supply. And this is Y and this is B. Okay, so I am representing the impedances. Let me say this is Z1, Z2 and Z3, and this is the load neutral point N dash, and this is the supply neutral point N. Okay, and this is your one phase, this is the other phase, and whereas this is your other phase. So we are having three phases, and you can see for the three-phase four-wire supply system, I am having three phases R, Y and B for the three-phase four-wire. Okay, four-wire. One is, this is a written wire. Okay, you are having the written wire, that is a neutral wire, which is at zero potential. Okay, so for the three-phase four-wire supply system, I have connected the three-phase loads. Okay, three-phase load. Let me assume it as a three-phase motor. Okay, this is one kind of representation. Now the other kind of representation is, let me say again, this is R, this is neutral, this is Y and this is B. and let me say this is A, this is B, and this is C. So again we are having here A, and for the neutral we are having N dash. Okay, and for Y we are having B here. From here I am talking. So let me say this is D. Okay, it would be easy for us. So Y is here we are having D, because B gets confused. That's why I am writing D. And for B here we are having C. Okay, again this will be your Z3, this will be your Z1, and this will be your Z2. So what I am doing here, it is I am connecting single phase loads, that is between the phase and the neutral. So here it is one single phase load, it is other single phase load, and here it is other single phase load. So this can be the two representations for the three phase four wire supply system. Okay, now when you connect the three phase loads to a three phase supply system, there will not be any unbalance. Okay, because the impedances in the three phase load or three phase motor will remain same mostly. Okay, or you can say almost. So the in the three phase load, or you can call it as a three phase motor, the impedances and the power factor will remain same for the whole load, and that's why when you connect the three phase loads to the three phase four wire supply system, then there will not be any unbalance in the system. Now where does this unbalance come from? So the unbalance comes from the single phase loads. So let me say I am employing fan load or a light load. These are single phase loads. Now it is rarely possible to say that this impedance will be equal to this impedance and this impedance will be equal to this impedance, because you cannot say mostly, or most of the times you cannot say the impedances of all the three single phase loads will be equal, or you cannot say the power factor of all the three single phase loads will be equal. Now when you introduce a single phase load in a three phase four wire supply system, then only the unbalance occurs. Okay, this is the main point here. And if you consider the IN here, we will be having the IN as IN will be equal to IA plus IB plus IC. Okay, so here we are having IA, IB and IC. Okay, sorry, this is okay, I will write it as IR, IY, IC. So this is IR, IY, IC. IN is equal to IR plus IY plus IC. This is the summation of three line currents. Okay. Now when you have the three single phase loads, then the line currents and the power will vary with some relative angles between them, as the loads are not balanced because the impedances of the three single phase loads, whereas power factor as well will remain different. Okay. Now let us take two important points here. So here we can draw the inferences regarding the voltage across each phase, okay, and the current in each phase and the neutral current. Okay, so here the IN is equal to IR plus IY plus this is IB, and here we are having the currents IR, this is I neutral, and this is IY, and this is IB. Okay, and one thing you can notice here it is, since the neutral wire has negligible resistance, remember, since the neutral wire has negligible resistance, the potential at the supply neutral as well as the load neutral will be same. So as the potential at the supply neutral and the load neutral is same, the voltage across each impedance will be equal to the voltage across the supply, okay, or voltage across the phase supply. So what I am saying here is, since this supply neutral and the load neutral is at same potential, the voltage across each impedance will be equal to the voltage across each phase supply. So this is one inference, and the phase currents or the line currents will remain different as the impedances are different. Okay, so that is regarding the V phase and I phase. And regarding the neutral current, that is IN, the IN is nothing but the phasor sum of here in the three-phase balance load. IN is nothing but the phasor sum of the three line currents IR, IY and the IB. And here your IN, that is a neutral current, depends on the magnitude of the line current as well as their phase relations. So the amount of the neutral current, it depends on the magnitude of the three line currents and their phase relations. And in most practical circuits, it is encountered that IN will be equal or smaller than one of the three line currents. Okay, it may be IR, it may be IB, IY or IB. Okay, so this is what we notice in most of the practical circuits. So this is regarding your three-phase unbalanced load. I hope you understood well. Thank you.